تمام. Okay. Good morning or good evening, doctor. Today we are going to present our project and what we have done so far. So basically, we are going to speak about a few points in our project. We will speak about introduction, setting up the virtual box system, process management, memory management, file management, and conclusion. Now, first, let's speak about our project. In our project, the we have focuses on exploring the basic process management in any system in general. We we creating a communication between the processes using named pipes and monitoring system through some commands that utilize and analyze the system resources. Of course, we are going to speak about how did we set up our virtual system. Okay, so basically we have select the ISO file, which is the Linux system. We put it here in the virtual machine. We gave it a name. We put it again as an ISO file here as it's shown in the picture. And also we have allocate to from 2 to 4 gigabyte, which shows a 4 gigabyte for better performance. And we, of course, it shows 20 gigabyte as a virtual hard disk size. And also when we install the system, we have to create an account. In the account here, we have about Osama's name, for example, with his ID and with the password as it mentioned here in this tips. Now, once the virtual system is completed, we have to report the virtual machine and log into the system. Now, as we can see here in this picture, it shows that the installation is completed. Then we have to reboot the system. When we reboot the system, it will show us the login page of the virtual system. And of course, we have already installed guest editions in VirtualBox to enhance the virtual machine experience, better display resolution, file sharing, etc. And to open the terminal, for example, this is the basic commands as it's shown here, the BW, LS, MKDIR, CHMOD, etc. Of course, we are going next to speak about process management with Muhammad.
Okay. Uh, Hello, Doctor. I will be talking about process management. To start about the definition, process management is a core function of any operating system. It involves creating and scheduling and synchronizing and terminating process. For our project, we explored these concepts. We started by first of all, we started by ensuring Python was installed in the system. It was necessary for scripting, inter-process communication. This was done by the code will be provided in the screenshot later. Next below is the code install the PT install system. Once by implement the process using Named vibes allow processing to communicate by writing within data. Uh, Also, for the scenario, we used uh, step one was write log message to a pipe. The second byte point is another process to read and display the image. The command used, as I said in the screenshot, uh, that allowed us to install Python. Next one, please. Moving on, this slides include the screenshots. As you can see, it import the OS time and random. We start by name of the name byte, if I if o student name underscore log, assuming our student ID. Then creating a function to write log message to the named byte with the student ID and calculation. Then we create the if I if o if it does not exist. Then we check the size of the create buffer. After that, we move on with the write the log message to the pipe, calculate the value based on the student ID. Then we can write a message to the named pipe by the line if I if o dot write then message. Ensure the message is sent immediately by using the command line if I if o point flush. After that, we introduce a delay between each log message. Random delay might be between 0.5 and 2 seconds. Then we create a function to read log message from the named byte, then read log message from the byte. Move on to the memory management process. Now, another slide. Can you move on, please? All right. For this slide, we will talk about the commands line, top and htop and ps3 and the use of it. For top, it display active process and the resource usage. And for htop, enhanced version of top with better visualization. For the command line ps3, show a tree structured of process and their relationship. For this use case, it used to analyze the system performance and understand the process behavior. Move on, please. Moving on to memory management. Memory management ensure efficient allocation and usage of memory to improve system performance. It used to allocate memory to process monitor. We can monitor memory usage and reclaim unused memory. Next slide, please. Now, moving on to the command lines for monitoring memory. The FreeH command line is to display memory usage in a human-readable format. Top and htop for real-time memory usage. Also, vmstat 1.5 to monitor memory swap and I/O performance over multiple iterations. Next slide, please. And this is the screenshot that will show after you enter the command lines. Also in the previous, can you go back to the previous screenshot? Yes. Also down below, you can see we use the htop, htop, and vmstat. It shows us the usage and the cache and everything, and free. Also FreeH show us total and the use and free and shared and the cache and available. Move on to slides front. Also, we explored the swapness, adjusting kernel parameters such as swapping. So swapping, we use the code sudo sysctl vm swapness, and we put the number we want. Reduce it. We used it to reduce reliance on swap memory, making the system faster. And for dirty pages, configure how long data remains in a memory before being written. to a disk. For example, the dirty background ratio we used. These optimization help improve system responsive and stability. Move on, please. For this slide will be with Osama. Go ahead, please.
Yes. So we know that the file management is an essential component of an operating system, which generates effective file and directory organization, access, and modification. File management can be accomplished via terminal commands or graphical user interface GUIs, with the later provided more flexibility and control. Basic file operations and permission management and user group ownership setups are examined in this section. Key file management operations. It's file and directory creation. Using the terminal, new directories and file can be created to structure data logically. For instance, creating a directory named ITGN, which is what we did for project files. Also generating a text file, file one text with the initial content using terminal command. So on the next slide, file viewing and editing. The cat command, which what we also will use and we'll show you in the next screenshots, allows for displaying file content, making quick edits, or combining multiple files. Editing tools like Nano or Getit provide more advanced options for modifying file contents. Permission management. Links employs a permission system to control access to file and directories. Owner was the user who created the file group, a set of users with shared access, all other system users. Permission include reading, writing, and executing. Commands like chmod allow modification of these permissions to enhance security. Here is an example of a basic command line in Linux, sudo command. And in the next slide, there is the cat, which is for creating files, reading and writing, which were used here. We at the beginning was showing files, no directory, but then we used it for reading the name and the ID and the course, which is it showed it. Also, the ownership management. Files and directories have an assigned owner and group using commands like chow and chgrp. Ownership can be reassigned. Example, here we assigned UD3215, which is my student ID, as the owner of the file, the file one backup, and setting the group to ITGN256. File duplication and backup. The CP command enables creating backups of crucial files, ensuring data safety. For example, duplicating file 1 into file 2 back. Access control. Access control, or ACLs in ACLs in the system can be managed to define precise permissions for specific users or group, ensuring that sensitive files are accessed only by authorized individuals. Example, this is the example from our project. If you, if you zoom, you can see this is the same screenshot that we used, that it explains the ACLs, the access control lists that we managed. So in conclusion, the summary of the project, we have provided a hands-on exploring the key of operating system concepts by using the system UBUNTU links and starting with setup on VMbox, which covers the process management and using memory management, which is important for memory allocation, which is important in order to have good memory management. Also, communication with the system through managing and processing the file by using tools such as TOP, HTOP, and non-file editor with Python code script and kernel optimization to enhance the tasks processes in operation system by combining theoretical knowledge with practical application. Our project build an optimization and advanced operating system. Those are the references. We use the course and your course, Doctor. And yeah, thank you so much.